To understand Open RAN, it is useful to first have a high-level understanding of how networks work.
What is Open RAN? Open Radio Access Network is a modern wireless network architecture that enables greater choice, flexibility, and agility for service providers deploying 5G. To understand Open RAN, let's first look at how other networks are built. A typical closed RAN uses proprietary interfaces between the radio and baseband units. This means a service provider is locked into that particular radio and baseband unit vendor, unable to mix and match vendor components for an optimal solution. An Open RAN architecture opens up these interfaces, giving operators faster, more flexible deployment options, while enabling new functionalities like network automation, analytics, and network slicing. And because they enable multi-vendor deployments, open interfaces contribute to a more competitive and vibrant supplier ecosystem, which is good for everyone. Open RAN, freedom to innovate, freedom to choose, faster to market.
What is Open RAN? Open Radio Access Networks, or Open RAN, refers to a disaggregated approach to deploying mobile networks by using open and interoperable protocols and interfaces, which allows for increased flexibility over traditional RAN systems. Open RAN can be implemented with vendor-neutral hardware and software-defined technology based on open interfaces and industry-developed standards. Traditional RAN. In a traditional RAN system, the radio, hardware, and software are proprietary. This means that nearly all of the equipment comes from one supplier and that operators are unable to, for example, deploy a network using radios from one vendor with hardware and software from another vendor. Mixing and matching cell sites from different providers typically leads to a performance reduction. The result is that most network operators, while supporting multiple RAN vendors, will deploy networks using a single vendor in a geographic region. This can create vendor lock-in with high barriers to entry for new innovators. Here is a quite informative video for us to better understand Open RAN deeply.
Hello everyone, welcome to this short video with an introduction to the Open RAN concept. Let's start by looking at a typical mobile network architecture. You have a core network, an access network. In between, they are connected by a transport network, which is also known as backhaul. Then there is the air interface, and a device or a user equipment, also called UE, that connects to the service provider's network. On top, there are services that run on the core network. The core network, as well as the access network, contain hardware and software. When we talk about disaggregated mobile network architecture, this is when the hardware and software are disaggregated or separated. This applies to both the access network and the core network. In this video, we will focus on the radio access network, or RAN. This is a picture of how mobile towers used to look in the 2G and 3G days. All the electronics used to be in one or more cabinets at the bottom of a mast or a tower. The RF cables would then run to the antennas on top of the mast. While this was a simple approach, the RF signal attenuation in the RF cable was a big problem. As a result, during the later phases of 3G and during 4G rollout, the industry moved to a new approach that worked better. Instead of sending RF signals from the cabinet to the antennas, the RF equipment was moved to close to the antennas. This ensured the RF signal loss was kept to a minimum. This new piece of electronics is known as the Remote Radio Unit, RRU, or Remote Radio Head, RRH. We can say that this contains hardware. At the bottom, we would have the baseband unit, or BBU, that would sit in the cabinet. This contained hardware as well as software. While in this picture it shows the BBU driving one RRH, in reality, a single BBU would be able to drive possibly all the RRHs that belong to the same vendor and operator. Looking at traditional RAN with a contemporary base station as an example, the RRH is always a proprietary hardware. The BBU is proprietary software running on proprietary hardware. And finally, The interfaces between the BBU and RRU are proprietary. The most popular protocol in use on fronthaul is CPRI, which is vendor-specific. When we talk about virtualized RAN, or vRAN, the RRH is still a proprietary hardware. The BBU is a proprietary software with virtualized functions running on a COTS server. But the interfaces between the BBU and RRH are still proprietary. It is worth emphasizing that vRAN is not necessarily Open RAN. With the Open RAN approach, the RRU is now COTS-based hardware that can be purchased from any ODM, OEM, or RAN hardware vendor. The BBU is a proprietary software with virtualized functions running on a COTS server. This is the same as in the case of vRAN. The main thing to remember is that the interface between BBU and RRU-RRH is an open interface. This would allow any vendor software to work with any vendor's hardware. This is the main difference about Open RAN as compared to other approaches. To explain this concept, let's look at an example scenario. A simplified view of a typical network is shown with proprietary hardware, RAN software and platforms, transport network, core, and services. Let's assume that the service provider has deployed Open RAN software from vendor V1 that runs on COTS servers. For the hardware, they are using RRHs from an OEM ODM-A. Now, let's say they are upgrading some sites or deploying new sites and they decided to use RRUs from another vendor, B. These should work with the software from vendor V1 out of the box because of open interfaces. Again, the service provider has decided to introduce a new hardware vendor, C, as they may either have more advanced features, or are lighter or consume less power, or any other reason. Again, these should work with vendor V1 software straight out of the box. Now, let's say the service provider is unhappy with software from vendor V1 because the vendor roadmap was not aligned to their own, or perhaps they do not have advanced features or any other reason. What they can do here is replace vendor 1 with V2. Because of open interfaces, the hardware from vendors A, B, and C should work with software from vendor V2. Now, when we move on to 5G, where instead of a BBU, we have central unit or CU and distributed unit or DU. While the backhaul and fronthaul remain the same, midhaul has been introduced to connect CU and DU. The same approach to multiple vendors being able to interoperate with each other continues in 5G due to the Open RAN approach. As you can see, the DU and CU vendors do not have to be the same, and the DU vendors should be able to work with the same RRH vendors because of open specified interfaces.
Open RAN. Open RAN is not a technology, but rather an ongoing shift in mobile network architecture that allows networks to be built using subcomponents from another variety of vendors. The key concept of Open RAN is opening the protocols and interfaces between the various subcomponents, which is the radios, hardware, and software, in the RAN. As a technical matter, this is what the industry refers to as disaggregated RAN. The benefits of this approach include increased network agility and flexibility, increased innovation, and cost savings. There are three primary elements in the RAN. First, the radio unit, or RU, is where the radio frequency signals are transmitted, received, amplified, and digitized. The RU is located near or integrated into the antenna. Second, the distributed unit, or DU, is where the real-time baseband processing function resides. The DU can be centralized or located near the cell site. Lastly, the centralized unit, or CU, is where the less time-sensitive packet processing functions typically reside. The interfaces between the RU, DU, and the CU are the focus of Open RAN. By opening and standardizing these interfaces, among other in the network, in incentivizing implementation of the same, we move to an environment where networks can be deployed with a more modular design, without being dependent upon a single vendor. Making these changes can also allow the DU and CU to be run as virtualized software functions on vendor-neutral hardware.
Good day, I'm Mark Jason Tilayog from Group 3, and today we will discuss the topic about Open RAN. What is Open RAN? Open Radio Access Network or Open RAN is a term for industry-wide standards for RAN interfaces that support interoperation between vendors' equipment. The main goal for using Open RAN is to have an interoperability standard for RAN elements such as non-proprietary, white box, hardware, and software from different vendors. Network operators that opt for RAN elements with standard interfaces can avoid being stuck with one vendor's proprietary hardware and software. Open RAN is not inherently open source. The Open RAN standards instead aim to undo the siloed nature of the RAN market, where a handful of RAN vendors only offer equipment and software that is totally proprietary. The Open RAN standards being developed used virtual RAN or vRAN principles and technologies because vRAN brings features such as network malleability, improved security, and reduced CAPEX and OPEX costs. A brief history of Open RAN. As lots of people point out, Open RAN is an idea or a movement. The fact is that RAN's radio access networks have consistently been closed, in that a mobile network operator or MNO had to buy every part of the RAN from the same vendor for it to function. There have been several attempts to change the so-called vendor lock-in. If you look back to when the WCDMA 3G standard was being defined in the 1990s, WCDMA split the RAN into two major components. The interestingly named Node B, the physical layer of the base station, and the radio network controller or RNC. One RNC controlled a group of Node Bs and the interface between them, known as the IUB interface, was supposed to be standardized so that MNOs could mix and match RNCs and Node Bs. Naturally, it wasn't in the vendor's interest to do this, so there was no shift or momentum to implement this standard. The major Open RAN organizations. The two most influential organizations working on Open RAN standards are the Telecom Infra Project, or TIP, and the O-RAN Alliance. TIP has its own Open RAN standard that is based on the tenets of disaggregation of hardware and software, open interfaces, and the flexibility. One of its main goals is to create a programmable virtualized RAN architecture based on a general-purpose processing platforms. The O-RAN Alliance's work is based on the core principles of openness and intelligence. The openness allows smaller players in the RAN market to launch their own services or customize their networks. The Alliance's solution to growing network complexity and demand is to embrace automation, artificial intelligence or AI, and machine learning to deploy, optimize, and operate the network. Open RAN architecture. The O-RAN Alliance is a well-documented architecture for Open RAN interfaces and elements. The key elements of the Alliance's O-RAN architecture are Service Management and Orchestration Framework, or SMO, RAN Intelligent Controller, or RIC, O-Cloud, O-RAN Central Unit, or OCU, O-RAN Distributed Unit, or ODU, O-RAN Radio Unit, or ORU.
With the telecommunications sector facing complaints of data congestion in this increasing data-hungry world, the Open RAN system is here to offer assistance to the telcos to provide better network connectivity and thus better data speeds. With the data consumption increasing every day, this surely will be a stepping stone to solve all those data worries of an end user as well as corporates.